Section 7.4, scientific notation. Essential question. How do you multiply and divide numbers written in scientific notation? Alright, so multiply. Write your answer in scientific notation. So we are going to start on this by multiplying the 2.5 and the 3. So 2.5 times 3 is 7.5. And then for the tens, we're going to take 10 to the third and multiply it by 10 to the fourth. So there's two ways to think about how you can simplify that. 10 to the third is the same as 10 times 10 times 10. 10 to the fourth is the same as 10 times 10 times 10 times 10. So if you count how many tens there are total, there's 7. The shortcut of getting 7 is adding your exponents. So 3 plus 4 make 7. So you can think of it either way. But I'm going to do the shortcut for the majority of the problems. So then I'm just going to group together my 7.5 and my 10 to the 7th to write my answer. So 7.5 times 10 to the 7th. I'm done if this answer is in between 1 and 9.9, and it is. 7.5 is between 1 and 9.9. If it wasn't, I would have to keep going. So I'll show you how to do that on a later problem that doesn't end up between 1 and 9.9. All right, second one, 3.7 times 10 to the 5th times 2 times 10 squared. So we're going to start the same way and do 3.7 times 2. So 3.7 times 2. So 7.4. And then I'm going to take 10 to the 5th times 10 squared. So really, I'm just adding my exponents. So 10 to the 5 plus 2 would be 10 to the 7th again. So I'm going to take the two of these and put them together. And my answer would be 7.4 times 10 to the 7th power. That answer is between 1 and 9.9, so I'm done. All right, 3.5 times 10 to the negative third times 7 times 10 to the 5th. So 3.5 times 7 will give me 24.5. And then I'm going to do 10 to the negative third times 10 to the 5th. So 10 to the negative third times 10 to the 5th. So negative 3 plus 5 would be 2. So if I put those together, I have 24.5 times 10 to the 2nd power. Now this answer is not between 1 and 9.9, so I have to keep going. So I'm going to put it into standard form. So I'm going to look at my exponent, which is positive 2, meaning my number is big. And if my number needs to be big, I need to move it 2 to the right. So now I have 2,450. I'm going to take this number and put it into correct scientific notation. So my decimal's at the end. I need it in between the 2 and the 4 to be in proper scientific notation. So then I have 2.45 times 10, and I moved my decimal 3 spots. 2,450 is a big number, meaning bigger than 1, so my exponent is positive. So 2.45 times 10 to the 3rd is my answer. All right, division. So divide, write your answer in scientific notation. So 6.6 times 10 to the 5th divided by 2 times 10 to the negative 2nd. So I'm going to take my numbers out in front, just like I did for multiplication, and divide them. So 6.6 divided by 2 is 3.3. And then for division, so multiplication, we added our exponents. Division, we're going to subtract our exponents. So 10 to the 5th over 10 to the negative 2nd will be 10 to the 5th minus a negative 2. So that would be 10 to the 7th. So if it helps you, you could write down subtract exponents. And you could add into the multiplying part, multiply or add exponents. So that might help you to add into your notes. So these ones are subtract the exponents. Those ones were add the exponents. So then your answer is 3.3 times 10 to the 7th. And that's between 1 and 9.9. So you're done. All right. 7.5 times 10 to the 8th divided by 2.5 times 10 to the 4th. So if I divide those, so 7.5 divided by 2.5 is 3. And then I'll subtract my exponents. So 10 to the 8th over 10 to the 4th is 10 to the 8th minus 4, which is 10 to the 4th. If you're wondering why we subtract our exponents, you could expand this. So 10 to the 8th would be 8 tenths. 10 to the 4th would be 4 tenths. And then to simplify, we just cancel them. So you're left with 4 tenths. So that's how we got this 10 to the 4th right here. So then if I group my two parts of my answer together, I get 3 times 10 to the 4th power. So that answer is in between 1 and 9.9, so I'm done. All right, two more. 3.545 times 10 to the 8th divided by 2.3 times 10 to the 2nd. So divide these. So 3.45 divided by 2.3 is 1.5. And then if I subtract my exponents, 10 to the 8th divided by 10 to the 2nd is 10 to the 8th minus 2, which equals 10 to the 6th. So here's the two parts of my answer. 1.5 is in between 1 and 9.9. So 1.5 times 10 to the 6th. I'm done. And the last one. So 2.106 divided by 7.8. Gives me 0.27. And then if I do 10 to the negative 5th divided by 10 to the 6th, I would subtract my exponents. So it would be 10 to the negative 5th minus 6, which is 10 to the negative 11th. So then if I put those two together, I have 0.27 times 10 to the negative 11. So a negative 11 for my exponent means a small number because it's a negative exponent. So I've got to go 11 this way because remember 0.27 is in between 1 and 9.9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I rewrite this number, there's a decimal, 11 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then I'm going to take that number that's in standard form and put it back into scientific notation. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my answer is 2.7 times 10 to the negative 12. It's negative 12 because that number, the 0.1127, is a really small number. So my exponent is negative. Summary.